Some simplifications. Here we've got the square root of 121. So let's think about that. 121, if we were to factorise that, let's do a little factor tree up here, then we just get 11 times 11, which equals the square root of 11 times the square root of 11, which equals 11. The reason I wanted to show you it that way is because that will become very helpful when we do this type of question. Obviously the square root of 121 is just 11. You should know your square numbers all the way up to 144 minimum, which is the square of 12. You should also really know the square of 13 is 169, the square of 14 is 196, and the square of 15 is 225. Those are all the square numbers all the way up to 15. All reasonable mathematicians should know those off the top of their head. Anyway, let's look at this question, because we're going to use this idea of splitting a number up into all the prime numbers to simplify it. So here we have 48. How can we write 48 if we use prime factorisation? Let's give ourselves a bit more space. So we've got 48 is equal to 2 times 24, and 24 is 2 times 12, and 12 is equal to 2 times 6, and 6 equals 2 times 3. 75. Let's do a factor tree for that. 5 goes into 75 15 times. 15 can be split up into 3 times 5, and we can't do any more than that. Another way, the nice thing about factor trees is it doesn't matter which way you do them. We could have started off with 25 times 3, and then 25 is 5 times 5, and still got the same answer. And 3, well, that's a prime number, so there's no point worrying about what that is as a factor tree. So if we write this all out, we get square root of 48 is equal to the square root of all these numbers times together, 2 times 2 times 2 times 2 times 3. And 75 is the square root of all these numbers times together, 5 times 5 times 3, and we've got minus the square root of 3. Now the objective of all of this is to find square numbers. And if you think about it, everywhere you've got a pair, you have a square number. So effectively, you've got square root of 2 times the square root of 2 here, and that just gives you 2. So everywhere you have a pair, you can take it out as a number. So that gives you 2, that gives you 2, and we're just left with the square root of 3 here that we can't square root. Remember, everywhere you've got a pair, you have a square, so that just gives us 5. Because root 5 times root 5 just gives you 5, and then we're left over with the square root of 3 here. And we just got the minus root 3. So 2 times 2 lots, which gives you 4 lots, plus 5 lots gives us 9 lots, minus 1 lot equals 8 lots of the square root of 3. And that is how we can add these all together. So notice I got these all down to the lowest form, so I took out all the square numbers and left with numbers which are not square numbers under the square root, and funny enough they all match up to be root 3, so therefore I can add them together because I have 4 lots, 5 lots, minus 1 lot. Okay, here we got the square root of 5 times the square root of 3, and that just gives us the square root of 5 times 3, which is equal to the square root of 15. We've got no numbers to take out, but this is definitely much simpler than writing this. We're going to look at this. Now, we did do the prime factorisation of 48 earlier. Okay, it was 2 times 2 times 2 times 2 times 3. So let's write that out. 2 times 2 times 2 times 2 times 3. All square rooted. All over the square root of 3. Now remember, once again, everywhere you've got a pair of numbers, you have a square. So therefore we can write that as the square root of 4. Square root of 2 times square root of 2 is the square root of 4, which is just 2. So that becomes a 2. Similarly, that just becomes another 2. In the same way. and then we just got times. We can't square root that, there's nothing to times it by to turn it into a square number. So we get 2 times 2 times square root of 3 over the square root of 3. Now because we've got the time, root 3 times all of this, and root 3 on the bottom, we can cancel these root 3's out. So these two will just cancel because we've got times here and here. If there was a plus here, we wouldn't be able to cancel them because we'd only have root 3 times this 2, not this 2. But because we've got times in between them all, we can cancel that out. And that just leaves us 2 times 2, which gives us 4. So I've cancelled out those two root 3's.